All right, some new terms for linear regression. Regression line, this is the line that best fits our data. And when I say best fits the data, what that means is that it's the one place you can put the line where the points on the whole are closest to the line. And that is going to be derived by some statistical calculations that involve the slope and the y-intercept. One nice thing about this is that a lot of the stuff that we're calculating with the slope and the y-intercept is stuff that we've seen before with correlation. And what we're going to end up doing after we create the formula for this line is that we're going to use it to predict individual scores. And then we'll assess through a variety of new statistics how well scores are predicted. And that's going to indicate the strength of our relationship, how strong it's going to trend with the strength of the correlation. And regression line is sometimes called the line of best fit or the least squares line. A couple other ways to refer to this. All right, the regression line, also known as the regression equation. I'll probably be talking about it more as an equation because I tend not to use the line. The line is less commonly used than the equation. Again, that's the formula for the straight line that best fits our data. The notation we're going to use is y prime equals a plus b sub y times x. And for any individual score, we can plug in their score on whatever the x variable is, whatever the predictor variable is, and find a predicted score for them. So A is the y-intercept. That's the value of y prime, or where you are on the y-axis when x is exactly 0. The slope, b sub y, is the amount of change in y, how much we're going up or going down on the y-axis for every 1 unit change in x. And when I say a 1 unit change, that's like going from x of 4 to x of 5. 1 point change, you can think of it as well. And the slope will be positive if there's a positive correlation, negative if there's a negative correlation. And as you'll see, we're going to use this to leverage a lot of calculations. I would say in this section, we're really going to explode the number of calculations that we're doing because there's a lot to calculate in regression. So just to visually show you, where's the y-intercept? The y-intercept is right about there. That's where x is around 0. So the y-intercept here is, almost 50, 40 something. Or let's call it exactly 50. The slope, that's how much we change in y. So from 10 points to 11 points, how much has y changed? One thing we can see is it's going down, right? So we've got the exact points. So we'll talk about how I get those y prime values. And we just subtract one from the other. The change is 0.07. And that is the slope, how much we're changing, how quickly we're changing. All right, a handful of real-world applications. Regression and regression approaches are really widely used. They're used in college admissions. Use high school grade point average, GPA, or ACT to predict success in college. You take data from previous years, you have that data about students, you use that to build predictions for incoming students. Car insurance. Number of accidents, tickets, age, gender, all of that is used to predict how much you're going to cost the insurance company over the course of the year, and then they balloon that by 10 multiply that by 10 or something, and that's what they charge you. Credit card limit, amount of debt on other cards, income, whether if you're younger, your card is co-signed. All of those predict the amount of maximum monthly payments possible, which allows credit card companies to set your credit limits.